In this video, I want to discuss radical functions. Okay, so these are functions underneath, surprise, surprise, radicals. For example, f of x is equal to the square root of 2x. G of x is equal to the cube root of 7 minus x. Those are two examples. Okay, and we know that they have limited domains because we can't take the square root of a negative number. Well, actually, we can if we're willing to work with complex numbers, imaginary numbers, but if we insist on sticking with real numbers, then we know that some radical functions have limited domains. Okay, now not all of them do. Okay, it's okay to take the cube root of a negative number, so that the g of x, the domain there, is unlimited. Okay, however, the f of x, that one, the x cannot be negative. It can be 0, it can be any positive number, but x can't be a negative number. So the domain for the first one is all numbers, all non-negative numbers is how you'd say it. Okay. Now, so in general, if I was to play this game, suppose I was to give you some complicated, let's say, something like this. And I was to say, tell me what the domain of the h function is. Okay? And so you think, okay, wait, hold on, I have a quadratic. How am I supposed to know what values make that negative? Okay? Well, this is where you can use your skills solving inequalities. Okay? So you would, for this one, you would say, okay, for what values of x is that literally, for what values is it less than 0? So you write it out like that, and then you go ahead and solve it. And you know how to solve it, or I hope you do. You first factor. Okay, and then we know that we've got two situations. They have to have different signs, first of all. So that means that you have a negative positive situation, or the other situation you have a positive negative. All right, and so we solve each of those cases. This is x is less than 3 and x is greater than minus 2. So you bring it all together, minus 2 is less than x is less than 3. That's the first solution. The other one is x is bigger than 3 and x is less than 2. And it's not possible to be bigger than 3 and less than 2, is it? So we have to completely throw out that situation. So we have to avoid x being in between minus 2 and 3. So we say the domain is, for h, the answer would be that x has to be less than minus 2, or x has to be bigger than 3. Okay, so that's how you play that game regarding domains. Okay, now let me finish this video by talking about the graphs and the inverse of two basic radical functions. So these are the simplest of the simple, and it would behoove you to memorize what I'm about to show you. All right, let's work with the square root of x, and let's work with the cube root of x. Okay, let's do the graph and the inverse of each. So the square root of x has a limited domain. That means we're not going to have anything with negative x. And the graph grows, but not very quickly. So it'll look like, starting from the origin, it'll look like that red. That's a sketch of what it'll look like. Okay? Now, the cube root also grows slowly. the right side looks similar to the square root situation, but it also allows negative x's. So that one's going to have a flipped something like this. Okay, so I would memorize those simple examples, and then via transformations we can get a lot of mileage out of memorizing these two pieces. Okay, and then let's also calculate the inverse. Okay, so let's do that here on the right. Let me do it at the bottom actually. So y equals the square root of x. Let's swap the x and y and solve for y again. Let's square both sides. So, well, there you have it. Y equals x squared. So the inverse function is x squared, but we have to the domain is limited, so it's only for x greater than or equal to 0. Okay, remember limited domains. Okay, and now let's do the cube function, cube root. So y equals the cube root of x. Swap the x and y and solve. We get y equals x cubed. So the inverse is x cubed, and that is not limited.